Hello, let's talk about gravitational potential energy. And gravitational potential energy is the potential energy due to gravity, okay? It's the energy due to position in space. And it has three components: mass of the object, the height of the object, and of course, in this case, gravity. And we'll deal right now with gravity on Earth. Okay, so mass has a specific variable. We have height has also a specific variable, and gravity, of course, will do that right now. And let's begin with mass. The mass is given in, or should be worth in kilograms. Okay. The height is in meters, and gravity itself is meters per second squared. Okay. So we have the three components. Gravitational potential energy has to do with the mass of the object in kilograms times the height in meters, okay, times gravity on Earth, in this case is meters per second squared. Let's abbreviate this and solve for the other variables. So let's call this gravitational potential energy, okay, equals, and let's call mass just m, and let's call height just h, and let's call gravity just g. So we have the three components. We have the mass times the height of the object times gravity. What if I need to solve for gravity? Okay, if I need to solve for gravity, I will move the other two components away. Okay, and I will bring the m down. Sorry about that one. I will bring the m down, and I will bring the h down. This is solving for gravity. Of course, gravity on Earth will always be 9.8, okay, 9.8 meters per second square. But if we leave the planet Earth, then that is going to change. Okay, so this one is solving for gravity. Good. Let's solve for now for mass. If I want to solve for mass, I will bring the h down and gravity down. Good. If you notice, I have not changed the potential energy on top. That has stayed the same. This has stayed put. I have moved the other two variables, and the one that I'm searching for has stayed alone. This one right now is solving for mass. Let's go back to the original. What if we need to find the height of the object? Okay, I will simply move these two components down, mass and gravity. Now I am solving for height. This one is solving for height. Back to the original. And just think of this one. Think of gravitational potential energy is the mass times gravity times height. Okay. If we inverse it, it makes no difference. Okay. It's still the same thing. The important idea that you need to think of is that whatever you're searching for, okay, you need to move the other two components to the bottom. Solving for gravity, bring that down. Good. Solving for mass, bring those down. Solving for height, bring those down. I never touched this. And the one I'm searching for has stayed put. Okay, let's do some examples. The question says, an object is placed 40 meters above sea level and has a mass of 2 kilograms. What is the gravitational potential energy? Okay, so this is the equation. Okay, I'm going to place it right underneath, right here at the bottom. Good. I am looking for this gravitational potential energy. I have the mass, okay, and the mass is 40. I have the height, sorry, the mass is 2 kilograms. The height is 40, and gravity is gravity on Earth. Okay, let's plug in these values. So I have the mass, and the mass is 2 kilograms, and I have the height, which is 40 meters, and I have gravity. Although it is not mentioned on the question, but gravity on Earth, we'll use it unless we're told otherwise, is 9.8 meters per second square. Okay, so here we have it. And let's plug in those numbers. And I have 2 for the mass, I have 40 for the height, and I have 9.8 meters per second square, okay, for gravity. What does that give you? I get a total of 784. Okay, so for now I need a unit. 784 what? 784 joules, because we have we know that energy is measured in joules. 784 joules. Okay, let's do one more. Sample 2 says, you go to a height of 15 meters and your total gravitational potential energy is 5200 joules. What is your mass? I am looking for mass. Okay, so I will paste here my equation, and I have this. Now, I am solving for mass, so I will leave mass alone and I will move the other two variables. Okay, I'll move the height, which I have, and the gravity, which I have. I am looking for mass. So what I have now is the energy, okay, due to gravity, which is 5200 joules. I will divide that by my height. And the height is, it says here 15 meters times gravity, which is 9.8 meters per second square. Okay, let's do the math. Let's see what we get. Good. So when you plug in 5200 joules divided by the multiplication of 15 times 9.8, be careful how you plug in those values. Okay, I get 35.37. 35.37, and that would be kilograms. You're not a heavy person, only 35 kilograms, like 70 pounds, a little more than that. Okay, so this is what I get. When I plug in 5200 joules over 15 times 9.8, I end up with 35.37 kilograms because I am looking for mass. Good. I hope this helps you out.